For centuries, human cultures have treated the vulture as a grim omen. We look up, see them circling in the sky, and immediately associate their presence with death, decay, and the spread of disease. Without this specific family of scavengers, human ecosystems would struggle to contain the very pathogens we associate with the birds themselves. Consider the Andean Condor. It is the apex representation of this biological class. These birds do not spread sickness. They operate as an elite, highly efficient biological waste disposal system, actively scrubbing the landscape of rotting organic matter before it has a chance to fester. This deep-seated prejudice has historically blinded us to the vulture's role. Because we rarely value what we find repulsive, we have allowed these essential protectors to become some of the most threatened animals on Earth. To understand how effective these scavengers are, you first have to look at their physical scale. Their massive size dictates their ability to clear vast territories of carrion. This graphic illustrates their physical proportions. A typical Andean condor boasts a 10-foot wingspan, which allows the bird to ride thermal currents and cover a 100-kilometer daily radius without ever needing to flap its wings. Once they locate a meal within that massive range, their internal chemistry takes over. A vulture's stomach acid sits at an extreme pH of 1.0, a level of corrosiveness that rivals battery acid. When vultures consume rotting carcasses, lethal pathogens like anthrax and rabies are physically dissolved inside their acidic digestive tract. Processing these pathogens internally prevents infectious tissue from lingering on the surface, stopping lethal bacteria from leaching down and contaminating the local soil and groundwater. Even their signature bald heads serve a specific hygienic function. Lacking feathers on their heads and necks prevents infectious blood and tissue from matting in their plumage while they feed deep inside a carcass. Every physical trait, from their wingspan to their bare skin, is optimized for disease control. They are highly adapted biological firewalls. Because they eat animals that are already dead, humans tend to assume these birds lack cognitive complexity or hunting intelligence. Yet, field observations show highly advanced problem-solving. Egyptian vultures, for example, pick up heavy rocks in their beaks and forcefully throw them down to crack thick-shelled ostrich eggs. They also maintain highly structured communal hygiene routines. Vultures regularly gather to bathe in clean water and sunbathe, utilizing ultraviolet light to bake off any remaining bacteria and keep their feathers aerodynamic. To gauge their importance, imagine a modern city where the municipal waste collectors simply stopped working for a single week. Garbage would pile up, and sickness would inevitably follow. Vultures provide this exact municipal waste service on a global scale. In their absence, that system stops, leaving the natural world with no mechanism to process the mounting weight of organic decay. We don't have to guess what happens when that system fails. We can see it unfolding right now in parts of India and Nepal. Beginning in the 1990s, the Indian vulture population experienced a sudden, cataclysmic mortality event. Millions of birds began dropping out of the sky over a span of just a few years. The trigger was a veterinary anti-inflammatory drug called diclofenac, which farmers had recently started using heavily on their livestock. This chart illustrates the chain of transmission. The drug starts as a pill given to cattle. When those cows die and are left in the fields, the vultures consume the meat. While their stomachs can dissolve anthrax, their kidneys cannot process diclofenac, leading to rapid, fatal kidney failure. Within a decade, that single chemical transmission eradicated more than 90% of the regional vulture population. Fields that once hosted highly efficient cleanup crews were suddenly littered with the bodies of the birds themselves, resting right alongside the untended livestock carcasses. The region's primary disease barrier was dismantled in a matter of years, initiating a dangerous biological chain reaction across the entire ecosystem. With the vultures gone, an immense ecological void opened up. Millions of tons of rotting carrion began accumulating in open fields and local waterways. This massive surplus of meat created an instant secondary crisis. Feral dog populations exploded across the region to take advantage of the uncontested food supply. Unlike vultures, dogs cannot neutralize the pathogens they eat, and they frequently interact with human populations. As a direct result of this shift in the scavenger hierarchy, human rabies transmissions from feral dog bites spiked severely. Reversing this damage requires a focused conservation response. Scientists have established captive breeding programs, safely incubating new generations and using hand puppets to feed the chicks so the young birds avoid imprinting on humans before release. Breeding programs are only one part of the equation. To successfully repopulate these species, we have to replace our cultural disgust with active protection. We cannot survive on a planet that loses its ability to clean itself. Protecting the vulture is a mandatory act of human self-preservation.